Alright, so let's say you're in this diagram here of two charges, and the question says to consider the system above, where Q1 is held stationary at x equals 0, and Q2 is allowed to move along the x-axis. If the potential energy of the system is equal to C over x, where C is a positive constant, derive an expression for the force exerted on Q2. To start, how is force and potential energy related? Previously, we know that work is equal to negative change in the potential energy, W equal to negative delta U. Previously, we also know work is equal to force times displacement, where F is the force factor and delta D is the displacement factor. So if we set these two equations equal by plugging in work equal to force times displacement, we get this expression here. We can look how this expression changes along one direction. If we choose the x component, the F vector is just going to be force in the x times x hat, which x hat's the x direction unit vector. And then delta D can be written as delta x, which is the displacement in the x direction. So we know that force times displacement is also equal to FD cos theta, where theta is the angle between them. And if we look at our force and displacement, we can note that they both point in the x hat direction. So this means that theta is equal to 0 and cos theta is equal to 1. So we can just rewrite it as this. If we plug this in and then isolate for the force, we get this expression here where delta U over delta x is equal to U2 minus U1 over x2 minus x1. And if we take the limit as delta x goes to 0, we get du over dx, where this is the infinitesimal change. And this is because if we look at a graph showing the potential energy as a function of x, this is going to be delta x and this is going to be delta U. As delta x gets smaller, we can see that our delta U also gets smaller. And so if we take delta x equal to 0, we can see that that's going to represent dx, and then our infinitesimal change is going to be du. So delta x going to 0 yields du over dx. So if we plug this in, we get this final expression for the force. This is the force as a function of the potential energy, where f of x is the force from potential energy in 1D motion. Note, if we look at the equations equal to the negative of the derivative of the associated potential energy function, we can apply this to our example. This is our example here, and this is our potential energy function. So if we just plug that into the equation that we just found, we get this expression. We can take out the c, since the derivative doesn't depend on c. We can use the derivative power rule given by this. If we rewrite 1 over x in this form, we identify that a is going to be equal to -1. Plug this into our derivative power rule, we can end up getting this. So if we plug that in and then do a simple cancellation, we end up getting this for the final answer. So this is the force felt by Q2 due to the potential energy of the system. Note, f of x is positive, which makes sense because Q1 and Q2 will want to repel each other since they are both positive charges. So their electric fields oppose each other, therefore there's a repulsive force between them. And so this repulsive force represents a positive force between them. Additionally, we can see that as x increases, the force decreases, which makes sense because the farther the distance between Q1 and Q2, the less force between them, since they're at a farther range from each other.